the second derivative we have. Can anyone tell us what is the second derivative? Yes. Minus 144x plus 60. I agree. So let's set this equal to 0 because it can never be undefined. So then 36x squared minus 144x and plus 60 equals 0. Definitely first divide by a number. 6. Yes. So I have 6x squared. It may not work with 6, but yeah, it will work with 6. So I have 24x plus 10 equals 0. Yep. And again by 2. 3x squared minus 12x plus 5 equals 0. Can anyone give us a factored form quickly, or you want to use the Corati formula? That's 15, 3 and 5, 15 and 1. It's not going to be factorable. Okay. Negative b minus 4ac, 20 times 3, 60, divided by 2x. Okay. So x will be 12 plus or minus. What do we have here? 84. Ugly. Okay. I don't care to fully simplify it. I have to approximate it anyway. We can factor out a 4 and the square root of 21, but it's not going to make a big difference. So 12 plus the square root of 84. To go outside, close the parenthesis and divide by 6. And I copy that with a minus. So one is 3.53 and the other one is 0.47. Of course, they have to be all squeezed in there. 3.53. Can I put it in? 3.53, 0. And the other one is 0.47. Of course. Okay, it's quadratic. It's a quadratic function. In between solutions will be negative, or you can check if you want. And outside will be positive. You can plug in a number. So this is the situation here. And now we have to identify those points. So let's talk about the points. Again, I don't like the fact that the numbers are so close. I need more room. That's why I created a new table. And now I got into another squeezing situation with these very, very close. I just like to have room between those numbers so I can explain what I'm doing. Okay, can anyone identify what this point is for us? 0, 0.
The y and x intercept?
Correct?
Or
yes, that's absolutely correct. X and y intercepts. What else?
Critical point?
Absolutely. Which one? Not critical point. It's called point of extrema.
Or relative extrema, yeah.
Which one?
It is if it goes from negative to positive, then a minimum.
Very good. Relative min. Good. 1,9. Noor, will you tell us? What is 1,9 for this problem, for this function?
Do I need to graph that first?
I would like to know what type of point is 1,9. 1.
Maximum.
Okay, very good. It's a relative max. Good. Anyone else? 5, negative 3.75. What type of point is that?
Minimum.
Very good. Awesome. Relative minimum. What type of point is this, which I haven't found yet? That's why I don't like it. It's too crowded.
Too crowded. Points.
Yes, but we have to find them. So 0.47 first and 3.53. Terrible, because I don't have enough room in my table. That's what it is. With 0.47, this is 4.3. And with 3.53 is negative 216. See, that's why I want my table to have room, to have air. It doesn't. So I'm going to circle so you know what I mean. So you know this is with this is with this. Okay, so again, what is 0.47 comma 4.3? Very good. IP as well as this IP. Why? Can anyone tell us why? Is 0.47 comma 4.3 an IP and the same here? Can
So
anyone?
when the graph changes concavity.
Why? Yes, excellent, but why? Look at the table and say why. Excellent, that's the answer, but why?
The sign changes?
For what?
Oh, for the second derivative.
For the second derivative, and the second derivative there is either undefined or 0. Very good, awesome. Okay, finally, I'm ready to graph. Okay, nothing matters but my table. I don't care to look anywhere else. Not a friendly situation. The numbers are ugly. Let's see. I have to start with the points I have, 0, comma 0. Okay, so that's 1. Then I have 0.47, 4.3. So how big? I'm having issues with this negative 216, negative 375. This is huge, right? Oh, we're going to handle it. So 0.4743. So I'm debating with myself about the scale. That's the thing. So I think I'm going to break the scale in the negative part of the y-axis, but not in the positive. Okay, so it goes up to 9. 2, 4, 6, 8, 10. Okay, so 0.47, so this is 2, 4, 6, 8, 10. Okay, so 0.47 and 4.3, 2, 4.3 right here. The other one is 1, comma 9 right here. Very close. 1.550. Very, very close. 3.53, 2, 4, 3.53, and negative 216. So I'm going to do a break in the negative side and say 100, 200, 300. Because I have no choice. Okay, so to 3.53, negative 216. And negative 5.245 here, negative 3.75. Finally, 246.45 right here. I see now, I understand the difficulty with this. I agree. It's an ugly one. Okay, ready. It's coming from positive infinity, opening up, decreasing to the origin. That is a relative minimum. Coming from positive infinity, decreasing to the origin, where is a relative min. Next, it starts increasing to this point, opening up, and at this point it will change concavity. Okay, it's increasing till this point where it will change concavity. Now it will be opening up, still increasing to 1, comma 9, which is a relative max. Opening up, opening down, increasing to 1, comma 9, which is a maximum, relative max. Now still opening up, but it's decreasing to 1.550. which is an x-intercept. Ah, yeah. Very close. Next. Still opening downward, but now it's decreasing to 3.53 comma negative 216, where it will change concavity. Why did this one move so far away? It was 3.53 to 3.53. Yeah, I have to graph it closer because it doesn't change concavity yet. So it's still opening down. Okay, and that is where it changes concavity. It will start opening down, opening up, and reaching this relative minimum. So at this point, changes concavity, it reaches the minimum, and then the rest is easy. It will cross the x-axis and go to infinity, as expected. Crossing the x-axis, reaching the relative minimum, crossing the x-axis, going to infinity, opening up. And this is f of x. One more time, 4 pages ago, what was it? 3x to the 4th minus 24x cubed plus 30x squared. I had no choice because I either could not see this, right, or it would be too small, or I would not be able to see this because this is too big. So this goes to negative 400. If you want to check with your graphing calculator, you can. I can show you. Where's my correct mouse? There's a different mouse. Okay, here it is. I'm sharing my screen. It's an ugly situation because of the scale. That's what the problem is here. So punch in the graph in y equals. So in y equals, we have 3x to the 4th. Clear everything else. 3x to the 4th. And then minus 24x cubed. And plus 30x squared. So now when I change the viewing window, I have to be careful. I don't care for more than negative 2 to the left. Nothing happens there. There is no action. I don't care beyond 8 at the most for x. But y is a different story. I want negative 400. And I want to go to 10. That's 10 is okay. Scale is not okay. Maybe 75, something like that. Doesn't matter really. But and now when I click on graph, let me see if I have anything in plots. No, my plots are off. Okay. So now I can click on graph, and I don't see anything at the top because I can change that. I can go back and change a little bit. And let's say y maximum, I'll go to 50 or maybe 75 if you want. So I can see, but it doesn't matter. It's not going to be anything in there. So it's coming from positive infinity. It has a turn. It has a local minimum. It has an inflection point, which the calculator cannot give. It has a local maximum, but the maximum is 9. Of course, okay, and then it crosses at to 1.55. It comes to a relative minimum, which happens to be also the absolute minimum. What was it? Negative 300. What was it? 375, and then comes back, crosses at 6 point blah blah blah, and goes to infinity. So that was the difficult part here. No matter what you do, the graph will look a little bit strange because of the scale. Very good. Thank you for bringing that to class. And there was one more question here. Okay, let me open that. Very good question. Thank you.